All right, Nancy, let's go ahead and kick off.
Well, great. Well, thank you so much. We're really thrilled to start off day 2 of the HKN Experience with our dear friends at John Deere. And I say that truly because they've been a great partner with EduCapanu and with IEEE, and very interested in working with all the students that are out there and the youth professionals in terms of not only sharing their expertise, but also in sharing the opportunities that they have to become an employee of John Deere. I know we got lots of HKN members that have been hired recently, and it's great to see the population growing. Well, John Deere's got a great session to talk about how technology is infused in everything they do every day, and they have the coolest equipment and the greatest stuff. So I'm going to turn this over to my dear friend and fellow Gamma Theta member for you HKNers out there. Amy and I are from the same chapter, Amy Jones of John Deere.
Thank you so much, Nancy. And thank you to everyone who's joining us today. We're so excited to share some of the fantastic things that we're doing at John Deere. One of the things that people think about when they think about our equipment is they'll often think about how big it is and how mechanical it is. And we're so excited to share all of the technology that goes into making this equipment and to really bringing it forward into the modern job site. So my name is Amy Jones. I'm an electrical engineer and I work in the construction division. I'm going to be introducing our panelists and moderating today. A quick note before we move into introductions, there is a chat, which is open, as well as a Q&A, which is open. As questions come in, I'll be moderating those and sharing them with our panelists, so please feel free to share. So we're going to kick off with some introductions today. I am going to ask Trent to introduce himself first.
All right, so my name's Trent Fleege. I'm the engineering supervisor of our electric drives team here at the Construction and Forestry Division of John Deere. So my team is responsible for all electric drives from concept all the way through qualification for the entire Construction and Forestry Division. So we'll work on any product line, whether it's a loader, a skid steer backhoe, depending on who wants electrification implemented in their vehicles. So if you think electrification, battery electric cars, hybrid cars, all that stuff, we're working on that for off-road equipment. I've been with John Deere for 13, almost 14 years now. My bachelor's degree is from UW Milwaukee in electrical engineering. I also have a master's in engineering management. Outside of work, I do farm on the side. So working for John Deere brings a lot of those insights from the farm back into my day job. I also play and coach a lot of different athletics in the local community here, and I do also enjoy traveling.
Thank you, Trent. Jake, you're up next.
My name is Jake Hansen. I work at John Deere as an embedded software engineer. I have 5 years of experience. The first 2 of those, I was focused on just the 4-wheel drive loader. And the last 3 years, I've been working on sort of a little bit on every single platform. My role is just to any embedded software, all the controllers in our machines, all the embedded systems, just work on stuff for that. For school, I went to Milwaukee School of Engineering, got a bachelor's in computer engineering, and it looks like my free time activity didn't update, but I really like cooking. I play a lot of video games, and then just hanging out with like my girlfriend, and I have 2 dogs.
Wonderful. Thank you, Jake. Next, we're going to welcome Kristen Cadman.
Hi there. I am a senior staff engineer and I lead a control systems group for John Deere. I've actually been here for 21 years now. I started out in hydraulics, and yes, I'm a mechanical engineer. But I've always had a love for control systems, and of course we integrate those fancy mechanical physics with fancy software, and that has been for a good portion of my career. And in my free time, I spend time with my family. I like outdoor activities, and that often includes travel.
Thank you, Kristen. And then our final panelist today is David Veasy.
Good morning. I'm David Veasy. I'm the engineering supervisor for our software product verification and validation team here at John Deere Construction. Basically, anything yellow that says Deere on the side worldwide, my team has the joy of testing the vehicle software that's on it, both to make sure it does what we expect it to do, but also that it's meeting our customers' expectations of it. We get to do that in a variety of different ways. We get to do it in simulated environments. We get to do it in bench environments as well as on machines. in the dirt in the giant sandbox a mile up the road from where I'm sitting at our proving grounds. So we get to get the real interaction between where the ones and zeros meet the dirt and rock, and a great interaction to be in. So.
All right. Thank you so much, David. All right. Quick reminder to everyone in the session that the Q&A is open. So if you have any questions for our team, we're more than happy to get those in. But to start off, I'd like to ask our panel, what do you wish that more people knew about the technical aspects of your job? And Trent, I'm going to ask you to go first.
Really just how complicated our systems are. I mean, we start talking about our battery, we have some battery electric vehicles that we've announced that we work on, and, integrating a battery electric system into a vehicle that's got to, lift big boulders and dig trenches and, do all sorts of different operations, and making sure that not only that vehicle performs like it's supposed to, but it feels correct to the operator.
Thanks, Trent. David, what do you think?
From a technical perspective, solutions can be super straightforward and simple, or very complex. And oftentimes it's not necessarily the complexity that trips up technical innovation. It is, how do you make it in a way that's sustainable so that you can continue to upgrade it and improve it over time? And how do you get people to trust it? How do you get people to trust the solution that you've put together, know it works, you've thought about it from every angle? How do you put it in the dirt and make people trust it and utilize it? You can have the best idea in the world, and if nobody knows about it or nobody uses it, did you really accomplish what you were trying to? And that is what I find is the hardest part of technical innovation.
I love that point about trust, David. Depending on your industry, we've seen it in automotive as people have had concerns about integrating new technologies, and it certainly exists in construction as well. Kristen, what about you? What do you wish that more people knew about the technical aspects of your job? If you're talking, we can't hear you.
I was. Can you hear me now?
Now we can hear
Thanks.
you.
Well, playing off of David a little bit in that trust, I think, is really important. But also, with trust comes teamwork, and that we need to take ideas and perspectives from everywhere. And I know with construction equipment, sometimes I will talk to someone else about some new product that we've got coming out, and I get the response I often get is like, oh, well, we did that. Like, that's been in automotive for the last 15 years, which might be true. But also, we have, like, there are rules associated with the road, and in construction equipment on a site, quite often, like, we don't have lines to follow, we don't have asphalt, we are changing terrain daily. So although it's superficially the same, it's actually quite a bit different, and it's not easier, it's not harder, it's just different. So I think that reinforces the fact that we need to take in lots of perspectives and that we win as teams.
I love that. It's totally true. Jake, what about you? As somebody who's a little bit newer to the workforce, what do you wish that people knew?
Yeah, one thing I know specifically, looking at like the software is how much, first of all, there's a lot of it, but how much it adds to sort of like the safety and like sort of like the nice to have features. There are a lot of things you might not think about that are just kind of being done in the background by the machine to make sure everything's run safe and efficiently.
So now that you know what we wish that you knew, the next question that I'd like to ask our panel is why? What motivates John Deere's emphasis on technology integration? And David, I'm going to ask you to take this one first.
Sure. We're all part of the world that we live in, and this world that we have is going to double in population from 2020 to 2050, and we have to feed that world. We have to clothe it. We have to shelter it. That's the point of why we're here in the first place. And we have to do that in less land and with less areas to farm and everything else. But we're on the construction side. So why is it important on our side? Well, half, if you look at some studies, half of today's current production of agricultural goods don't make it to market or don't get consumed. And that's because of the infrastructure, the roadways, the bridges, the various aspects, plumbing, pipelines, everything else that goes into that. We truly make impacts on how to improve the lives of not just our customers, but of the people in our communities and the people around us. And we get to do that with applying whatever technology we can find that's going to solve a problem to make it happen within our equipment.
It's a good feeling to know that what we're all working on makes a difference for people in a really real and concrete way. No pun intended. Trent, from your perspective, what do you think motivates John Deere's emphasis on technology?
And kind of do another level of that too. Everyone knows what the workplace demands are. There's less and less, I'll say skilled operators, a guy that can go in and run a, David's very familiar with motor grader, how complicated that machine is to run. There's less and less people there that are able to do that, and being able to still do that work with someone that's maybe only got a couple years experience instead of 40 years experience doing that. Making our customers not only more productive in what they do, but also making them more profitable and than their everyday, jobs that they have to do.
Kristen, what do you think?
So, yep, we definitely have an emphasis on technology right now. And yet, when I look at my career, I think for the last 20 years, we've been building up to this. And 20 years ago, when I started and we were talking about electro-hydraulic systems, some of my senior engineers would say, oh, we did that 10 years ago. And really, right now, I think the industry is ripe for it. Where technology is at, it's every day is getting more and more affordable. And really, like where we're at right now, I have been waiting for this moment for 20 years, literally. The sensors are cheaper, cost effective, and durable. Um, our computing capability is I couldn't have dreamed of this when I started, and now it's affordable. Like maybe I could have dreamed of like a Cray Research uh, cooled with liquid nitrogen type computer, but not practical in construction equipment. So just our capabilities, I really think that we've been building up to this, and I think it's a great time to bring attention to what we can do on our equipment.
Which is one of the reasons why we're here.
Yeah.
Jake, I have a separate question for you that I'll then shift to the rest of the panel. Technology iterates really quickly. And how are you staying up to date and relevant? And we're actually going to start with Jake, and then we're going to go through and end with Kristen, who has the most experience. So, Jake, how are you staying up to date?
For me, a lot of it, I try to get a lot of news from external because, especially in the software world, things are changing so much, and there's so many, different people sharing about other projects and their tools and stuff that are out there. So, I think I kind of end up using like the same like Google account personally and at work. So like I get a whole bunch of like in my news feed about different technologies and different things that are changing, and I learn a lot of new things about that and bring some of them to work to improve what we're doing.
Thanks, Jake. Trent or David, what do you do?
So my aspect's probably very similar to what Jake does, right? Is kind of monitoring what different industries are doing. Automotive, whether it's automotive or aerospace, and they don't always directly couple back to what we have to do on off-road, but some of the concepts are the same. So that, and also we do, my team especially, we do a lot of, we're coupled with a couple universities that are very focused on electrification, electric drives, one of them being the WIMPAC school up at UW-Madison. And we were very closely tied to their professors up there and what they're working on, from developing new technologies and motors. It was cool to see a bearingless motor, so the rotor just floated there, and as a concept that they're working on. So keeping in touch with the future of what these components might be.
I think we have some Wisconsin connections in the chat, so it's wonderful to hear about those partnerships. David, what about you? I mean, similar to Jake, software moves really fast.
Yeah, one of the things, the most useful thing I have utilized to stay up to date has been to lean on my network. The network that you build through supplier relations, whether you build it through university relations, as Trent's mentioned, as colleagues of yours move throughout the organization you're in, or even into non-competing areas around you. Leveraging that shared knowledge, and no, you don't get into the proprietary aspects, but you get a good pulse of what type of problems are people trying to solve, and how are they solving them. And that combined consciousness of your network is what I use to try to stay ahead of what's going to come at us next.
That's been something I haven't expected as I've grown in my career. I used to think that networking was really just people above you in an organizational hierarchy, but the most valuable parts of my network have been peers who've grown up with me. So I love hearing that. Kristen, the question for you, I'm going to twist just a little bit. So I want to know how you stay up to date and relevant, but you're very unique in that you're straddling multiple disciplines. I mean, you're an incredibly inventive mechanical and hydraulics engineer. You live in the controls world now, which couples with a lot of software and electrical and machine performance. And you've done that over a really impressive 2 decades. So for you, I want to know how you stay up to date, but I also would like to know how that's changed over the course of your career, if it has.
Oh, yeah. So this is fun. I would say, just simplistically put, over the course of my career, I'd like to echo David. Just that network is huge. Suppliers, universities, colleagues. Um, that has been huge. One thing I'm going to add to that, and I did not appreciate this early in my career, but patent reviews. Patent reviews can be very thought provoking, and it's a great way actually to monitor what we might think the competition is doing. Also, it's one of those things that you don't have to get too deep in a patent. You could gloss the pretty pictures, but just it's really thought provoking, and sometimes it helps you look at a problem a different way. And when I look at all of that, and if I look at how that changes in the over my 20 years, in the beginning of time, it was really all networking and maybe an occasional trade show, which I always like because it's lots of customers. And as we sort of move towards patents, like Google, and I know that's becoming a very casual term, but internet searches and everything that is available out there, and YouTube videos, the internet. Um, I am older than the internet. Um, the internet was the cool new thing when I was a freshman in college, but the availability and the tools to access that information have just monumentally changed. And how often it's available to you. I might be talking to someone and we'll look it up on our phones really quick, or, oh, what is this? Or what's available? Or what's this supplier's latest product? Um, just having that information at your fingertips really makes the discussions, it's supportive of discussions going faster, and faster creativity and innovation as well.
We'll have to share a thank you note to the keynote speaker from yesterday, who is one of the fathers of the internet.
Yeah.
The next thing I'd like to talk about is things that aren't maybe quite as fun and easy. I'd like to hear, what are some of the major challenges that you face when we integrate technology into John Deere machines? And Trent, I'd like to start with you for this one. And feel free to go deep.
Yeah, so overall, I mean, we've had John Deere's been around for a very long time. We've had, our construction equipment for a very long time, and they started out with diesel engines and hydrostats, whatever for drivetrain. And over time, our customers have learned to use those machines and use them in various different ways. Now, when you start adding technology to those, how they're used is slightly different, and then trying to change that mindset of, okay, a customer does it this way today, but if we gave them this new technology, how would they use the machine in the future? And being able to answer those questions as we're trying to develop the technology and work through the requirements of what that technology really needs to do. And the other piece is, we've got we had a nice picture of a skid steer up here on this, or probably a track loader, I imagine, compact track loader, up on the screen here. And, what that machine does, really what the machine does is really a power unit, right? It doesn't, once you take the blade off that machine, it doesn't really have any other function besides provide power to what that, whatever is attached to the front of it, in this case is a blade. But you're really focused on that function at that point. And there's a lot of people that will get, focused in on what's the solution right away. It's got to be similar to what we have today, or we can only make a small change from what we have today. And they're not focused on what do we actually need to perform? What function do we actually need to do with that system that we're developing?
Takes me back to the very first engineering design class that I think a lot of us took around brainstorming and trying to be creative and think about possibilities as opposed to what we're familiar with. Still similar challenges today, even with the more complex things we work on. Jake, what about you? What are some of the challenges that you've faced so far?
So some of the big major challenges are sort of, with software and technologies that's changing and keeping up to date with it. Because every time you get like a new type of controller that you got to work and get on a new machine, there's so much that needs to change. And, from other people who might not are so familiar with the software, it's like, oh, it's just a different part and, plug it in. But there's a whole lot of like communication and things you have to manage, and things take a lot of time, especially when you're making big changes from, an example of going to a different controller or maybe using like a different internal tool. So stuff like that is one of the big challenges.
One of my favorite statistics is that there are more lines of code on some of our John Deere machines than there were on the first space shuttles. So it's a big, big project to try and understand all that complexity and make sure that it all works perfectly the first time. Kristen, what are some of the challenges that you face?
So earlier we had talked about teamwork a little bit and specialties, and really the biggest challenge is when we integrate technology, there's so much to know. And um, we have a lot of very mechanically minded people who think software and electrical systems and electronics are these magical things that happen. And then we have electrical and software people who maybe don't appreciate some of the details. So sometimes that can um, really make for a few difficult situations and misunderstandings. And I really appreciate open mindedness and good communication. And when we talk about in school, if you want to be an engineer, you should be good at science and math. And I think we really underemphasize communication. And I found this early in my career, and 20 years later, I still find that in my career is that being able to take really complicated things and break it down in a way that someone with a different perspective can understand. Communication is just an ongoing challenge, and it's something that sometimes we need to remind each other of.
Absolutely. David, what about you? What are some of the challenges that you've faced when integrating technology? And I'm going to ask you to think back to your previous role too, because you were one of the pioneering product lines for some of these really groundbreaking, again, no pun intended, technologies on the motor grader platform.
Yeah, absolutely. So I spent 9 years on the design side doing electrical hardware and systems design before coming to the test side of our product teams. And I used to want to run as fast and as wide open as I could. We had an idea how quickly can we get a proof of concept out there and start playing with it. And what I learned is that ideas, and this might be difficult for some to hear, but ideas are relatively easy. Getting them to happen is really hard. And getting them to happen the right way and to execute in delivering them back to what I said at the intro of sustainably. So, when something goes wrong, how to fix it and how to fix it quickly, or how to improve upon it, how to build trust in it, and how to share that consciousness, as Kristen kind of hit on, of getting those perspectives to align to see the problem from different angles and make sure you're covering all of it is the most difficult part. And what I've learned is some of the most mundane tasks that are needed in part promotion and just keeping everybody aligned in the communication are the most pivotal. And because they keep that combined consciousness going, and it's hard to put the focus in there when you want to run really fast, but you have to, because if you don't, you're going to run off into a direction that isn't sustainable or doesn't get you where you want to go. And taking the team along with you is just as important as being the first person there. And that has been, from a technical challenge, how do you find ways to carve out those mundane tasks? How do you script and communicate effectively and put tools in place so that the team can focus on the hard discussions and the hard points of engineering, and take as much of that mundane work that's very critical, but not as technical? How do you get that to be the smallest part of your job that you can?
It's all about focus and putting the emphasis on the most important pieces.
Yeah.
David, you mentioned sustainability, which was a beautiful lead into a question that we have from someone in the chat. I'm going to direct this question at Trent first, I think. What are some of the ways John Deere currently uses tech to address the issue of sustainability?
Well, that's most of my life right now, so I should be able to answer that pretty good. So right now, my team is doing electric drives and electrification. Predominantly our main focus is for our hybrid and series electric type of applications is reducing that fuel usage of the vehicle. So trying to be as productive as possible with the least amount of fuel. So updating our drivetrain systems or hydraulic systems, whatever they might be, and looking for ways to electrify them and make them more efficient. You get a little bit of gains here and there, 5, 10, some of our vehicles that our 644, 944 that are in the field, will get about 20% better fuel economy than the conventional version of that machine. We're also very invested in our battery electric technologies. If you've paid attention to some of the news we've released about a year and a half ago, that we're working on a all battery backhoe, and we're continuing to work on that and find ways to bring that into production, bring that into mainstream, and in a way that is still viable for our customers to buy. So if we have a battery electric machine that's so expensive that customers can't afford it, or they don't see the profitability of that machine over a conventional machine, doesn't really do a whole lot for you. So bringing those technologies in and alternative energy sources into the marketplace and making it so that our customers want to buy those over the predecessor machines.
Absolutely. The economics are very different for a business purchase rather than, say, an individual or a consumer purchase, which is what we see a lot with automotive. Anybody else from our panel want to speak to any sustainability?
I do.
You're up, Kristen.
So Trent does a lot of really neat stuff with electric drives and the battery electrics. And one thing that I find is I touched on communication before, but one thing that I find is a really common language is energy. So whether you're mechanical, you're hydraulic, your structures, you're electrical, and you're doing all this cool tech stuff, there's a lot that can be done through simulation and accounting for the energy as we go through our machine. If you think of an engine, even not only is it reducing fuel, but those engine engineers are how much is going into heat, how much is going out into the stack. And when we talk about what comes out the stack, that is directly relates to what goes into the air, and all of the tiering regulations that we've had on diesel engines. Um, and it's sustainability not only for how we use our energy, but also the infrastructure. Trent also mentioned the e-backhoe, and it is a great idea, and there's a lot of work to be done to make that feasible, because just like with your cell phone, there's the charge anxiety, like, oh, will I make it through my day? So, you know, a few of us have touched on how hard it is to get something into production. Can we do it? Yes. But can we do it in a way that is useful and meaningful to our customers? Like, that is really hard. So, the problems are huge, and they're fun problems, and we need technology to help us through it.
Absolutely. There's no feeling better than delighting a customer. David, what do you think about this?
Yeah, slightly different spin. Definitely agree with both Kristen and Trent, but a different spin away from our equipment into some of our technology solutions. Our grade control solution is all about helping the operator put the blade in the right position and moving material very accurately. And that material cost on a job site can be pretty large. We try to, a lot of the grade control systems out there are plus or minus a half a golf ball or better. Some are a little worse depending on what optionality you do. But if you think about that golf ball at an inch, and I know golf balls I think are about an inch and a half, but an inch over a mile roadway that's 20 feet across is, if I did the math right, somebody can correct me on it, the number will still be big, about 10,000 yards of material extra if they do an inch over on the whole job for 1 mile of roadway. That's a lot of material that has to be pulled out of the ground, has to be shipped, has to be transported from the quarry to the job site, has to be use energy to grind it up. If we can get better with the resources that we use to build the infrastructure, or if we look at our ag side, the resources we use in our see and spray technology and our planning technology to minimize the amount of inputs into the work that we do, the better we're going to be stewards of the resources we have within this world.
Absolutely. The next question from our chat, I'm so excited about. Jake, I'm going to ask you to take this one first. What are some technologies or innovations that you would like to see integrated into our products, both in the near future and in the farther future? What possibilities are you excited about?
One thing that I've been following a bit and been pretty interesting is the Rust programming language. I've seen it gotten a lot more use in certain embedded systems, and it just kind of, it's very similar to what we use currently, like C, but it's got a way of sort of guaranteeing sort of runtime safety. And I saw something recently in the automotive industry, like the AutoSAR, whatever that group there. Actually, I saw some requests talking about using like the Rust programming language in some of that equipment. So I think that'd be a really cool thing to integrate into, our development process.
Absolutely. Kristen, what about you? What excites you about the future?
Really, just what excites me is actually where we're at is I'm very proud of, but I also have a how far we have to go. And that really is more from an imagination perspective, and some of the techniques that will change how our engineering methods and our implementation methods will have to change and adapt. It's some things are just in terms of implementing techniques, and in learning new things. 2 years ago, I took a class on object-oriented programming, and right away, I'm like, oh, we could do this, or we could do this, or if we think about the work site, I started thinking of the work site more like a video game than like a work site. And so the how far we have to go, like that's really it's not a daunting task. It's I can't wait to see what we do sort of perspective.
Absolutely. Trent, what about you? What's exciting to you about the future?
To me, I think it's really is how do we start or how do we continue to take this what we're developing now and advance it even further. Kristen mentioned before about the hydraulics, working on those 20 years ago where we, instead of having a pilot control lever, you can do it electronically, makes it easier to do, makes it more comfortable for the operator. Now, 15 years later, we start adding sensors to that and we control the blade for you. Again, we're making it easier for you. We're making it more productive. Now we've got, drivetrain systems that can very precisely apply torque to your tracks or your tire, or very tightly control the speed. And then we've got blade systems that can accurately, manage a blade. Now, how do we put those together, connect them, and not only connect them on the machine, connect them to other machines? and control a whole job site and make that job site as productive as it can be with the machines that the customer has.
I love that. And David, what about you? What do you get excited about?
I look at two things. At the end of the day, if you really think about why do we come to work? Why does anybody, not just engineering, but anybody, go to work? And it's to provide for your families, to allow you to do what you want to accomplish within your life, a lot of times outside of work. So from a safety perspective, our customers are in one of the most dangerous professions still in existence today. And finding ways to apply different technologies to make their job safer, and finding unique ways to get, we still have construction workers working in a 6 or 8 or 10-foot trench in the ground. And how do you get them out of there so that they're not even in the line of fire, and still able to accomplish the productivity and production that we need to keep up with the demands of a growing world. So that safety aspect in the technologies that we can grab, not just from automotive or aviation, but even what can we do in the consumer electronic space, or what can we take from manufacturing or the various different disciplines out there and apply it to make these jobs more safe, is definitely where I'd like to see this going. Making it more available for everybody to go home at night, and enjoy that time.
It's a fantastic use of that network that you talked about earlier, taking all of these different opportunities and bringing them into the construction world. Another question from the chat. What level of autonomy are you building into the machines? Are they networked? And if they are networked, how is cybersecurity now part of your daily job concerns? And I'm going to open that up to anybody from the panel who'd like to take a crack first.
I'll take a stab at it. I get a little bit of visibility to that. So our machines are not networked together or to the job site directly currently, but there are different network aspects that we are integrated with. If you look at our GPS guided machines, both on the ag and construction side, we use RTK radios, and which essentially is a radio base station that sends out corrections via either an internet or a radio signal to those machines. And therefore, there is some connection from that standpoint. From a cybersecurity, we are absolutely worried about it. We're worried about cybersecurity, not just from the networking side, but what happens if somebody plugs a component or a device we're not aware of into our machine, and what impact will that have to our equipment? If you look at, a lot of individuals who do cars or trucks, they chip their ECU, they'll plug into the diagnostic port and update different values to give themselves more power or more torque, things like that in vehicles. If you do that in our equipment, what's that going to impact, and how do we safeguard against that? Not to burden a customer in any way of trying to accomplish what they need to with their machine, but to ensure that the brakes are still going to stop you if you increase the power, and that you can support the weight, or the steering is going to feel the same, and vice versa. So a lot of the steps we take is, in data validation and ensuring that we have handshakes between the components within our vehicles, and ensure that we get good data correlation, and we focus a lot of fail safes. If something doesn't look right, what is the safe state? What is the safe situation to put the machine in until it figures out what it should be listening to, or can get the proper service that it needs. And that's both at that job site level as well as on the, even in that on machine level. And one of the ways we approach it.
Absolutely. A hacked car is kind of scary. A hacked bulldozer, I'd argue, is a little bit scarier.
Absolutely.
Trent, Kristen, or Jake, could you talk a little bit about some of the machine data, the telematics, some of the things that are being done there with respect to automation and giving our customers access to machine data to make them more effective?
Yeah, I could touch on it a little bit. From my aspect, we don't do a lot of I guess for me, it's more of a one-way communication thus far, right? Taking data off of the machine using our, data logger or our MTG to, send that up to the cloud and us using that data to analyze the performance of the machines or help us develop the next machines. So we get a lot of data off our machines, and some of our prototype machines we send out to the field, we get more data from that, more data than we'd ever know what to do with. And taking that data and parsing it down to information that we need. Some examples we had of having a machine at a customer site that was a prototype and had a problem. We were able to log into some of that data and figure out what the problem was fairly quickly within an hour or so of that machine having some problems, and able to get some software fixes there sent to the customer and have them back up and using that machine within a half a day or so. So from my side, that's usually where I'm using those telematics. I know there's other applications as well.
Kristen, you mentioned that after some classes, you started to see the job site as almost a video game. Do you think there's a future in automation and machine-to-machine communication within that work site?
Absolutely. Actually playing off of what Trent said and looking at it like a video game, um, out in the industry, there's like this point where it's like, hey, I have these machines, I have this task to do, and if we think of like some of the early the world civilization games where you have these great big armies and you've got the archers and you've got the guys riding the elephants and you've got the hand-to-hand combat people, like you don't tell each of those groups in the game, hey, go shoot arrows, like you guys go shoot arrows. You just say this group go fight this group, and then because they're archers, they know what they do. And so a four-wheel drive loader is never going to excavate like an excavator, but if there is dirt to be moved, both machines can move dirt. And so abstracting the job site like that, like really practicing abstracting, it first of all is probably harder than what you think, but wouldn't it be cool if that's how we looked at the world, like that video game? But to get there, there's a lot to do. And, the data that Trent is talking about, that is all going to be useful. There's often how we engineers think our customers use their machines. And then there's the reality of how the customers really use their machines. So there's a lot to be learned in those gaps. And it actually might even, data will transform for the customers how they use their machines. I had a job this big. Maybe historically, they just take an estimate, like a time and material estimate, but now they can better look at what machine combinations they have available, what the material type is, and plan accordingly because they can make data-driven decisions off of past jobs. And just it enables us to partner a lot better with our customers and get that video game job site someday.
Wonderful. Jake, there's a question in the chat that's directed at you. The question is, are the embedded systems in the machines running an OS or are they bare metal?
So they're running sort of our own real-time operating system that we've kind of developed here at John Deere. It's something that it's like a 20-year-old code base that we keep running, and so that's something that's going to be common in pretty much every single controller. So it's our John Deere operating system.
Thanks, Jake. I think we have time for about 2 more questions. So I'm going to ask this question and I'm going to change the picture on the screen to some information about our job opportunities at John Deere. And we'd encourage anybody who's interested in working with the kinds of technologies that we've talked about, who's interested in making a difference in a really sustainable and concrete way to check out our job opportunities and also talk to us during Power Hour. So the question is, what is a typical team size for a project? Does it vary? Is there a standard team organizational structure applied? Does the team use a life cycle model like V-cycle or Agile? And I'd also extend that a little bit to talk a little bit about what it's like to work on these complex projects at John Deere. David, could you start for us?
Yeah. So the first pass is that there's no one standard way that we approach each section. We look at our products in 2 or 3 different ways. You can look at it at the machine form, or you can look at the technology that makes up the machine form. Both are important. Both have teams supported to support that style. So where we'll have an engine team or a grade control team or a controls team that's working on each of those individual products, there's very matrixed. And then you'd have a group that takes all of that together and makes a motor grader or a bulldozer, and ensures that the integration of all of those components together is meeting the end goal customer's needs of that crawler or grader. So because we have those different structures and different sizes, some teams are very large and manage better in either a V-shaped model or because they're very waterfall-ish, they can go from that level, or you can be very agile if you've got depending on what your cadence is and how many different stakeholders you're trying to appease. If it's one product line, pretty easy to say we're going to do this, then this, and when these things are ready, move on to the next. When you are a central group and you're trying to balance 5 or 6 different stakeholders, I can fit X amount into this 2-week sprint, X amount into this 8-week PSI, and here's our cadence from that perspective. Because of that, Deere is a big company, but we have a very small field. We each have a huge part to play, and we get thrown right into the mix very quickly and very early. My first role was I had all electrical hardware on motor graders, period. Anything with a wire on it, my responsibility at that moment. And I think if you ask Kristen or Trent on their teams or Jake what his role is, right now, it's equally as large and making that impact. And thus, the connections that you make across teams tend to be impactful.
Absolutely. No time for interns to just spend time getting coffee and filing. We need you on machines doing the cool stuff right away. Trent, Kristen, Jake, would you like to share anything about what a typical project looks like or what it's like to work at Deere?
So actually, I'm looking across our panel here. All of us are in what we would call a central role within our division. So we're in a group that supports all of our product lines, depending on the projects and the priorities and stuff like that. We also have teams that work specifically on the product line. So their main focus is to make sure a backhoe is as good of a backhoe as it needs to be, from structures, hydraulics, engine, all that stuff. So what my team does a lot of is when a backhoe wanted to do a battery electric project, we go in and we support them. So my team ends up being almost more like a service organization where we go in and provide a service to them to help them integrate an electric drive system into their vehicle. From an aspect that's really cool, it's awesome to be able to work on all these different vehicles, but kind of the Kristen's point before on communication, it makes communication a really, really big deal. And being able to go in and integrate yourself with sometimes a completely brand new team for us that we haven't really worked with before, and understand what their needs are, what they're struggling with, try to solve those problems, try to explain some of the new technologies that we're developing to them and how that can help them do what they need to do.
Thank you for sharing, Trent. Kristen or Jake, anything you want to add on that topic?
I think they both hit that fairly well. And, like we talked about, there's the structure of John Deere, there's the V-cycle model or agile model. The communication is key, but if you take principle for any team that I have ever worked on, even before we had names for how we did things, the small cohesive groups are great for executing quickly. But David talked a little bit more about sustainability, what it takes to get to production in a useful manner. These small teams also need to work within a big organization. Often we'll talk about a matrix organization, and we definitely have one. And so it just sort of reinforces some themes of it takes all types, and communication is key.
Absolutely. Well, we're coming to the end of our time, so I'd like to ask each of the panel members to share a quick answer to our last question. And the last question is, in your opinion, what is the most important or your favorite innovation that you've worked on? And Jake, I'm going to ask you to go first. And you're muted if you're trying to talk.
Yeah, my mouse got stuck on the other screen. The favorite thing I'm working on is something I'm working on right now, which I'm having a lot of fun with. It's sort of like a common way that we do all of our output for our controls, and this is something that we're putting on, every single machine that we're building. It just handles, handling the output, handling any kind of issue goes wrong with the output, and it's really enjoyable to kind of work at that and really understand like the hardware. But as well as like I'm working really closely with someone in Kristen's group because we're taking this same kind of thing, we're putting it in the lab, we're evaluating how every single like hydraulic valve we put on functions, and so it's for me it's enjoyable to kind of have to work on something that's affects so many different machines at the same time. So
wonderful. Trent, what about you? What's been your favorite?
So I'd say my favorite thus far has been the 944, which would have been on our opening slide would have been the machine in that picture. We started working on that, I'll say back in 2005-ish timeframe. And that for us was at the time was a brand new machine form, or not a new machine form, but brand new machine size for us. It was the biggest machine we've ever worked on. So not only it's a loader, but it's a mining face loader, so I think it's a 126,000 pound machine. So not only was it a new machine for us, it was also a new drivetrain. That's a wheel motor technology, so there's an electric motor in each one of the tires, which was very different than anyone's ever done in the industry, and it was also a very new machine to us. So we kind of jumped face first into a big pool of learning with that machine. And not only did that machine kind of disrupt the marketplace a little bit because Cat had a major stranglehold on that size class of machines. They were like 80-90% of the market share for that size class of machine. So we jumped in and we were able to compete in that market now. But it also laid the groundwork for a lot of the electrification projects that not only we're doing here at CNF, but it's also the electrification projects you'll see coming out of anywhere of John Deere, whether it's ag and turf. A lot of the people that worked on that 944 team are now designing electric drive. The F9 EIVT you might have seen come out recently, which is an electric drive transmission on a 8R tractor. A lot of the same team members doing the 944 did that project as well.
It's exciting seeing that growth and that path towards that electrification technology. David, what about you?
Yeah, I was fortunate to be the integration lead on our John Deere Smart Grade motor grader, which was the industry's first massless guided grade control motor grader in the industry. So we beat Cat to the punch by about a year and a half. And we did it in a way where we used these very sophisticated hydraulic cylinders with a sensor inside of them that tells the length of each. So I can, at any moment in time, tell the blade tip of the machine to the frame. And why that's important is not just for the GPS guided grade control that it put in place, that they had, for the last 20 years, but they had to do it with a mast on the end of the blade that limited functionality and productivity. But more importantly, it laid the groundwork for a bunch of automation that we were able to accomplish right afterwards. We were able to use that same technology, those same sensors, without adding any cost, allow to simplify every operator's time of just turning the machine around or getting ready for the next pass or getting calibrated. We cut hours of work out of people's days with that technology, and we are continuing to grow. That team is continuing to grow the technology and the solutions on top of it. So laying that foundation and watching it grow has been the best part of that innovation.
Thanks, David. And Kristen, real quick, what's been your favorite?
My favorite is, generally speaking, might be our failures. There was one project, it was an electro-hydraulic backhoe. Not a failure. However, it very quickly went in and out of production. And why I like it is we learned so much on that project. And you can see a piece of that project somewhere in every product line um, that we do control systems on today. And I think generally speaking, we learn a lot. And I don't think that project was a failure. I think if you look at it from a marketing perspective, they'd kind of be like, meh, there's a reason why we don't make them anymore. And yet the impact of that project on the industry, on CNF, and really just how we go about our business, it really shifted things. And sometimes they're great successes. I think Trent's example with a 944 loader is a great example of that and how that laid a foundation for how we move forward. But really, that backhoe project is probably one of the high points in my career.
Just
Well,
to echo that,
yeah.
that smart grid project would not have been anywhere near achievable without the learnings from that backhoe project Kristen had mentioned. So I would highly align with that.
Well, if you'd like to hear any more about the cool things that we're doing at John Deere, about some of our favorite projects, maybe even some of the things that didn't go the way we thought they would, we would love to talk to you all. So please enjoy the rest of the event. Thank you so much for your time and your attention. And we hope to be speaking with you soon.
Thanks, everyone.
Thanks, everyone.
Thank you.